Okay, so last week we stopped at this section for density. I made a very bold statement last week saying that you guys all of you managed to solve density questions without the need for a formula. Remember me saying that? Yeah, that is important to me because learning science is not about understanding the formula, not about using the formula, it's about understanding what's going on. So I still eventually have to show you what the formula looks like. So I'm going to start the lesson by showing you what the formula looks like. But let's start by looking at the density. Okay. Look at the unit of density. You will have seen, or in the questions that you're going to encounter, you will see things like this. Last week, I talked about this something per something. I mentioned this statement, something per something. Let me show you. Remember at the start of the lesson, I mentioned about something per something. What we are looking at is one example of that. In this case, it is 10 grams per. So I can write this as 10 grams per cm cube. Right. So can you see this is the something per something. Now, what does grams really measure? What does gram really refer to? Anything that is measured in grams, kilograms, actually we are talking about its mass. I started the lesson by telling you mass and weight are different. So 10 grams is actually the mass. And what do you think the cm cube actually refers to? It refers to the volume of any object. And what does per refers to? Remember what I said about per? Who remembers what does per stands for? Divide. Very good. Divide. So what we have here is actually telling you mass divide volume is what density stands for. So the unit can tell you a lot of things. Therefore, I tell my students, do not memorize the formula. Instead, you want to understand what it means first. Then later, you can use the formula to do things fast. So what does D stands for? D stands for the density. If you ever want to find density, you can do that very quickly by taking the mass to divide by its volume to find the actual density value. My personal preferred way is for you to remember what density means. So let me repeat. Density, to me, it is the mass in 1 cm cube. Remember I talked about chopping off the finger analogy. Did I mention that? So if I can take out 1 cm cube and find the mass, you have found the density. That's how it means. Okay? Then, this is an appropriate place to tell you, do not be surprised to see this instead. Let me give you an example. What if you see things like kg per meter cube? It is also referring to density. So this part here is your mass. This part here is your volume. So what is the full complete picture? The complete picture is this. Your density can appear in a few different forms. It could be in gram per cm cube, or it could be in kg per meter cube. Okay, I'm going to ask a question. This is not the one, but just want to see who can answer me. Why is it in meter cube, we start to use kg, but in cm cube, we use only grams? Anybody know why? Okay, pause the video here first. Remember in Intro to Science, when we first met in December, did I not use a 1 meter ruler to explain to you how big 1 meter cube looks like? 1 meter cube is a cube that is made out of 1 meter by 1 meter by 1 meter. So can you imagine something that is called 1 meter cube? Agree it's going to be very huge looking? You want to use grams to describe it, or you want to use kg to describe it? Kg, right? Because it's huge. Understand? But something that is very small, like 1 cm cube, would you want to use kg to describe something very small, or you want to use grams to describe something small? Understand the reasoning now? That is the reason why it's common to see gram per cm cube and then kg per meter cube. Okay, I pause the recording. I'll give you time to copy whatever you see here first. Then I move on to the next part.